Hi, today we will be going through pigmentation of the skin. So we will take a look at what three main pigments are able to give us a wide variety of beautiful skin tones that we see. All right, so beginning with our first pigment, this is probably the most familiar to you, one that you have heard about the most, and this is melanin. So melanin is going to be the most common one that we often talk about. It is the one that we will focus most on in this class. So when we are looking at our melanin, melanin is a pigmentation that is going to be created in membrane-walled granules of melanocytes. So remember, our melanocytes were a type of cell that we introduced to you guys in the epidermis layer. So the melanocytes are going to exist in the stratum basal, that is the deepest layer of the epidermis, and these membrane wall granules that create our pigment are going to be known as our melanosomes. Be aware of what a melanosome is. So these little guys right here are both melanosomes, and we will talk about them a little bit more as we go along. All right, moving into how melanin gets transferred. So we know that melanocytes are going to exist in the very bottom on the basal layer, and that layer is going to contain all of the very fresh and young keratinocytes. Now we know that keratinocytes are going to exist layers 1 through 5 in thick skin and layers 1 through 4 in our thin skin. So what is going to happen is that these melanocytes are relatively big cells in comparison to the keratinocytes, and they are going to contain what are known as their spider legs. These are often also referred to as dendrites of the melanocyte. So these spider legs or these dendrites are going to reach up into the upper layers of the basal layer and into some of the higher layers that exist in the epidermis, and they are going to be how we are able to transfer the pigmentation from our melanocyte that is creating the pigmentation into our keratinocyte, which is where we are going to actually see the pigmentation be present. Now, our basal layer of our keratinocytes are going to contain much more melanin than our keratinocytes are going to be higher above. And what we're also going to see is that our keratinocytes are going to contain more melanin than the melanocytes themselves. So think of the melanocytes kind of as a production facility. So they are just going to produce the material and then they are going to transfer it to the keratinocytes. So we're going to put produce material. So our keratinocytes are going to be the actual storage or buyer of that material. Now, what is the importance of our melanin? So, in evolutionary terms, melanin is used as kind of a natural sunscreen. So we'll go ahead and put this, so natural sunscreen. And it is going to help protect our DNA from UV damage. Now, oftentimes when we talk about UV damage on skin cells, we often talk about skin cancers, which is a great way to think about it. So when we look at UV damage, we do have some harmful UV or harmful types of UV rays that can actually go in and denature or destroy the DNA that is within a cell. What can happen when this DNA is destroyed is that we can have what is known or what is called a mutation. That mutation can then result in a overproduction or unregulated growth of these cells, thus creating some kind of skin cancer, whether it be a melanoma or a little like carcinoma or like, a smaller portion that can be taken away. So we will see that this DNA protection is going to be due to the high amounts of pigment that are secreted from the melanocyte into those keratinocytes. All right, so we do have two different types of melanin. The first one is going to be our eumelanin. So this is going to be our black and brown pigmentation. This is the melanin typically found in those with a darker complexion. And then our pheomelanin. This is going to be our red-yellow pigmentation. So this is going to be found in those with a lighter complexion. So in the image right here on the right hand side, just to give you guys a little kind of quick rundown that is here. This is the base body of the melanocyte that is right here. And we can see some of those nice little dendrites that are going to, or the spider legs that are going to stick up into the keratin. Now, what we can see here is that these little legs are kind of sticking out, right? And we're going to see that they're producing pigmentation, either pheo or eumelanin, within that melanocyte. Then from there, we are going to see that that material is going to be secreted out. So here, all of these little dots right here, you can see this is that pigmentation being secreted out. Now, luckily for you guys, in the context of this class and for most anatomy courses that you guys will take in the future, you do not need to know how the melanin itself is created. Instead, you just need to be aware of the melanosome being used as a vessel for that pigmentation to travel from the melanocyte into the keratinocyte. All right, so looking at how melanin is processed in the skin. So we have two different images right here. So the first image is, or sorry, two different portions of this image that is here. So in our first one on the left-hand side, this is going to be our eumelanin. And then on the right-hand side, this is going to be our pheomelanin. All right, so what is happening when we are producing these two different types of pigmentation? So our melanocytes are going to produce melanin, so they're going to produce some kind of pigment, and that pigment is going to be created through a process known as melanogenesis. Be aware that this is the process that we are creating that pigmentation. So when we are creating that pigmentation, depending on if we are eumelanin or pheomelanin, our process for secretion is going to look just slightly different. So for our first process, what we're going to see is that once we've completed our melanogenesis, we are then going to transfer that pigmentation to the end of the dendritic cells. Now, what will happen is these little dendritic ends, and let me change my pen color here. So these little dendritic ends right here at the very end of the spider legs, these guys are actually going to reach into the keratinocytes that are around them. And what they're going to do is they're going to break through the plasma membrane that is going to exist on that keratinocyte. So this is sometimes known as the engulfing portion, or a time when we have the dendritic tip of the melanocyte being consumed by the keratinocyte. So this this dendritic tip, or the spider leg, is going to be is going to have two separate processes. So in our pheomelanin, the dendritic tip for part 2 is going to be pinched off. So what is going to happen is that portion of the keratinocyte is going to wrap around it, cut it clean off of the end of that melanocyte's dendritic leg or spider leg, and then it is going to take the melanosomes that are inside of that and begin to digest them. So when it begins digesting that melanosome, that is where we are going to get the release of that pigmentation. So those smaller amounts of melanin granules are going to be dispersed into the cytoplasm of the keratinocyte. In our eumelanin, we are going to see a little different bit of a process. So in our pheomelanin, we are actually pinching off the end of it. But in our eumelanin, we are going to secrete our granules of pigment through something known as exocytosis, or also known as like release. So we're kind of pushing it out in little bits and pieces. So instead of the end of that spider leg being taken off, this portion is going to enter the keratinocyte, and then it will be broken down just enough to where we can allow that exocytosis or that transfer of pigmentation to occur. So we're going to put exocytosis here. Now, what you may notice in these images is that within the areas, we're going to have large concentrations. So these are going to be our melanosomes here. So large concentrations of pigment. This pigmentation is going to reside within a small capsule or vesicle. And even though the outermost portion of that is going to be dissolved, we will oftentimes see that pigment still kind of clumped up together in one certain area of the keratinocyte. Now, in the case of the exocytosis that is happening with our eumelanin, we are going to see that we do have certain areas where that pigment or those granules have been released. So these are known as our cytokine secretion. So be aware of this. So cytokine secretion is a process where we are going to see the melanin be moved into those cells. And in this case, it's going to be moved in by exocytosis. So we'll put a little star here. All right, so once we have moved our pigmentation, whether it is by being pinched off or being sprinkled out through that secretion, we will then see that the cell is triggered by the completion of transferring that pigment, and the cell will then continue on with the rest of its life cycle. So at the stage here, we are going to be, and let's fix this. So at this stage here, we are going to be little, let's say, teenager cells. So we have, came from that stem layer, we have differentiated, moved into the stratum basal, and now as we're in the stratum basal, we are going to start deciding what our process is. So we're still very full of life, we're still very young, happy, healthy cell. We're still doing a lot of metabolic processes at this point. By the time we are doing our cytokine secretion, let's say that this is going to be an adult cell. So this guy has determined what his job is going to be. He has done some kind of, level of metabolic processes. He has gone through, he's living his life, doing what he needs to do. By the time he is done with receiving his pigmentation, he is like a midlife adult cell. And he is going to carry on with his life all the way until he reaches our stratum corneum. Oop, let's go back one more. Reaches the stratum corneum, and then that is going to be where that cell eventually dies. All right, so moving into another diagram here. So this is going to be another diagram showing our eumelanin. This is really great example. So here you can see that basement membrane. You can also see how that interaction between the spider leg or that dendritic tip looks in regards to the relationship with the keratinocyte. So here we can see that this is going to be the transfer of those melanosomes, which are going to contain that pigment. So they're literally just moving them into the keratinocytes. Now over here, we are going to have, so this whole area right here, this is going to be cell communication. So cell communication between our keratinocytes and our melanocytes. So not only do melanocytes give keratinocytes some of their color, but they are also notorious for giving that keratinocyte kind of the push to begin its life cycle. So it has now received its pigmentation, it's picked up the main purpose of its life, and now it can go ahead and continue on into the upper layers of that epidermis. So we see a very healthy relationship between the melanocyte and the keratinocyte, aside from gaining that pigmentation. All right, looking at our next pigmentations of the skin. So number two is going to be our carotene. So when you hear carotene, first thing that you guys should think of is carrots. So there's a reason beta carotene sounds a lot like carrots. So beta carotene is going to be a yellow-orange pigment that we find in a wide variety of fruits and vegetables. Primarily, when we talk about carotene being a pigment in the skin, we oftentimes think more of vegetables than we do fruits. So, what is going to happen is, in some cases, due to either diet or a health condition or a very weird adverse react to medication, a person may have a pigmentation that gives the hue of a fluorescent orange. So, this is something known as hyperkeratemia. So this is going to be high amounts of keratin that is going to exist in the blood. What we are going to see is that this most often occurs in younger people who are trying to maintain weight for some kind of event. So we see it a lot with our wrestlers. We see it a lot with weightlifters, people who need to be within a very small range of weight for a certain specific matter of time. They will oftentimes eat lots and lots of carrots. So carrots are relatively dense nutrition, like when we talk about the nutrition, but they do not contain too many calories. So they are a great snack to be able to keep something on your stomach, but not have to worry about large amounts of retention of water. I've had several friends throughout my life who have literally eaten so many carrots and sweet potatoes and squash that their hands have gained that orange hue. And it is absolutely insane to see in person because it almost looks like their hands were stained with yellow food dye. We will see that when we have large amounts of beta carotene that is being collected in the tissue, most of the time it is going to accumulate in the stratum corneum. That is going to be the uppermost layer of our epidermis. So that is the horn layer. So that is going to be the layer that we are seeing the most abrasion happen. Now, in severe cases, and this more so is going to be in people that are having certain health conditions or adverse effects to medication, we may also see it collected in the fat of the the adipose or fat tissue of the hypodermis. That one is not as common in the younger crowd. That one is usually more common in the older population. All right, looking at number three. So, number three should be a word that you are very familiar with. So, hemoglobin. This immediately you should think of blood. So, remember, heme, that is going to be our protein in our blood. That is always first prefix that you should think of is like the heme protein. So, what is going to happen in cases of people who lack melanin, whether this is they are lacking darker melanin, or they have very small amounts of things, or as something as pheomelanin, or maybe they have albinism. They are going to have a epidermis that is nearly transparent. When we talk about transparent, it is so clear that you are able to see the tint from the blood supply. So the capillaries that are going to exist in the dermis, so remember those capillaries are going to be able to just barely reach our epithelial tissue. That is the only place that our epithelial tissue is going to have any contact with our circulation of blood. And so what we're going to see is that the movement of blood through those capillaries can give the skin either a pink, red, or even blue hue. Now, most of the time, we're going to see this occur in the older crowd, and this is something known as cyanosis. So this is going to be typically where the skin is very thin due to aging, and as they begin to get older, that pigmentation becomes much more clear. So if we look at the image that's right on the side, here in the kind of lower portion of the hand, you can see that red or pink hue to it, whereas here we have a slightly blue hue to it. So that blue hue can come from low oxygen or poor circulation that may occur. We know older people, oftentimes they have very poor circulation in the fingers, the hands, and the feet. And so we can see some of that darker coloration that may occur due to the transparency of the skin as they age. All right, so this is something that is not on your exam. It is supplemental, but I do want to introduce it to you just that way the following slide and the video that we will watch will make sense. So we have something known as the angle of insolation. So this is going to be the degree of solar radiation that is hitting a certain area on the planet. So when we go back to very, very basic, oh my God, the cats are fighting. Why does this always happen? What is okay? Are you guys done? Thank you. Thank you. That's very nice of you guys to fight in the middle of the recording. All right, so what we will see is our Earth is on an axis, right? So we know that the Earth does not sit at 90 degrees, and we're going to pretend that this is like a happy little Earth, right? Super duper cute. Let's maybe make like Central America here is like, I don't know, something like that, right? Make the Horn of Africa right there. Okay, close enough. So what we know is that the Earth is on an axis. This means that for certain portions of the year, the northern hemisphere is going to be facing the sun, while the southern hemisphere is facing away from the sun. That is going to give us our seasons. So that is going to give us summer in the northern hemisphere and winter in the southern hemisphere. Now, we know that halfway through the year, the angle in which we are facing is going to change. So that is going to be our summer and winter solstices. This is going to be when our northern hemisphere transitions and kind of pulls away, starts facing away from the sun. That gives us winter time. We are now not getting as much daylight, so we're staying a little bit cooler. And then in the southern hemisphere, they are now facing closer to the sun, meaning that they are in their summer months. They're getting lots more longer days of sunlight, lots more radiation. So when we look at the planet, how does the angle of insolation actually work? So what is going to happen is areas that are in the equator or in tropical regions, they are getting direct sunlight all year long. It does not matter which way the earth is tilted. They are getting essentially 90 degrees of direct sunlight, regardless of the time of year. This means that the people there are going to have high amounts of exposure to UV radiation. So if we look at B right here, we have a very short distance and it is going to be a degree, uh, 90 degree insolation, meaning it is dead on. If you're to take a flashlight and you want to shine on something, you want that flashlight at 90 degrees to be able to ensure that you're getting the most concentrated amount of light. So we are having high concentration of light or of UV. All right, in an area where we are closer to the poles, so whether this is northern or southern hemisphere, doesn't matter. When we are looking at regions that are typically 60 degrees latitude and up towards the poles, those areas we are looking at about 30 degrees of solar insolation. So what this means is that we have a lot of solar radiation that is being spread over a much larger distance. And so that is going to reduce the amount of UV radiation that is hitting that area, or the amount of UV radiation that is reaching the surface, I should say. So we are going to have lower concentration of UV rays. All right, so this is important because when we talk about where evolutionarily our melanin types have developed and where we have theories on why we have certain areas that have higher amounts of melanin compared to others, it will go back to this angle of insolation. Now, if we were to take a little peep at where roughly we are, this is going to be me taking just a wild shot in the dark. I actually do not have the number pulled for this, but for, for our own sanity's sake, we are going to say that here in Virginia, we are roughly about 45 degrees for our solar insolation. So what that would mean is if we were, let's say we are right about here. Obviously, this is not to scale. This is also probably not a very accurate placement of that of where Virginia would actually be. But what we are going to see when we look at our solar radiation that is coming in from the sun, we're going to see that we are still spread over a pretty decent amount of area. So let's go ahead and mark that out. So we'll say that this is going to be about 45 degrees. And we'll say this is VA. And then we're going to have our little sun that's right here, nice and happy, right? Giving us all the sunshine. Give them a couple more little rays there. All right, so we can see the difference in that solar radiation from somewhere such as, let's say that this is Canada, Virginia, and then let's say that this is somewhere like Hispaniola. All right, so just to give you guys a rough idea on how the angle of insolation works and looking at how the angle of insolation that goes over a theory of why certain pigmentations developed and what would be the evolutionary benefit of certain pigmentation. So having, a darker complexion versus a lighter complexion and where those geographically may have arose from. So this image right here is a rendition of a map that was created by Dr. Nina Jablonski and Dr. George Chaplin. So we will actually watch a video that shows how this map was created. Please pay attention to that video because that video is going to have questions that will show up on your exam. It is a really great video. I will have it linked in the landing page when we get there. So looking at our angle of insolation, there was a theory that was developed basically about the correlation to how much UV radiation is present in a geographical location and the amount of pigmentation that was found, and we're talking like historically, so like very beginning, early man, and the amount of pigmentation that was typically found in those areas. So why may this be important? When we look at this map, we are going to see very high concentration. So if we're just gonna, roughly say that this is about the equator, give or take. Obviously, the Earth is round, and so that line would look a little bit different when correctly drawn to scale. So roughly say that that is our equator. We can see that we tend to have higher amounts of our eumelanin there. So that is that black and brown pigment. In our areas where we are going to be 60 to 90 degrees of latitude, so those are going to be regions that are typically very cold. So think of like Canada and up, think of like the Arctic and Antarctic. Those areas we're going to see very high amounts of our pheomelanin. So that is going to be that yellow-red pigmentation. Now, what we are going to see here is that in this area, we have very low amounts of UV radiation or very, very low access to it because remember, it is spread over a large area. In the equatorial, so we're talking the equator to about the Tropic of Capricorn, equator to about the Tropic of Cancer. So this is going to be high amounts of UV radiation present here. And it's going to be very concentrated, consistent radiation. So we're talking all year long we are having very hot, continuous weather, whereas some of the areas that are north of these tropics are going to have that seasonal change or that variation in the amount of UV light that they're getting through the year. So this is important because we have something known as UVB. So we do have quite a few different UV types. UVB is the one that we will focus on in anatomy because it is the one that directly helps us produce vitamin D. When you go outside after being inside, think of COVID times, you're locked in the house and you finally went outside and it was nice and beautiful, sunny, and you just stood there and felt the sun on your face. There is a reason that that feels so good. It is because that UVB radiation is helping our bodies produce vitamin D. Now, vitamin D is going to help us process and intake higher amounts of calcium, which leads to us having a stronger skeleton, so stronger bones. Vitamin D is also going to correlate to nerve health. So when we talk about the nervous system, vitamin D is a very important supplement to have in the system to ensure that the nervous system is functioning properly. So vitamin D, UVB radiation, very, very good. We want it so that way we have a strong skeleton, and then also so that way we have a healthy nervous system. Now, with that same token, there are other UVs that are not as healthy for us to be around. UVA is usually one that we talk about when we were talking about skin damage. Sunburns, those are ones when you see the UV being very high on the weather app, that is usually going to be higher amounts of UVA present. So UV radiation and something known as folate. So folate is also known as vitamin B9. There are lots of vitamin Bs. We're only looking at the ninth one right now. And this one is going to be important in our red cell formation. So red cells, remember vocab word here, those are going to be our erythrocytes. So our erythrocyte formation and cell function. So this is going to be any metabolic process that a cell is performing, whether this is removal of waste, production of ATP for whichever designated cell this is going to be, or if this is going to be the replication process for a cell. Now, our folate is a very important vitamin when we talk about pregnancy and health of sperm and reproduction. And it is something that oftentimes, when you look at the composition of prenatal vitamins, it has very, very, very high amounts of folate added into it, just to ensure that there is healthy development in those early stages. Usually, that first trimester is like that key time to ensure that we have high amounts of folate for that growing fetus or embryo. Now, when we look at how folate and UV radiation interact with each other. So extensive amounts of UV radiation can actually degrade or break down folate, meaning that the larger amount of UV radiation that we may be getting, so in areas such as the tropics or the equatorial regions, that is going to reduce the amount of folate that we are going to have in our system. And this is talking about in a scenario where we are not supplementing this material. So we have no additional medications or materials going into the body to help with this. So when we talk about melanin, specifically our darker complexions, they are used as a natural sunscreen. They're going to reflect UV light. That is very, very good because that is going to allow us to have synthesis of vitamin D. So we're still getting that UVB radiation, but it's not allowing us to have too much UV radiation where it's breaking down and destroying that vitamin B9. Now, if we were to have somebody who has high amounts of pheomelanin present in that same location, so in that tropical or equatorial region, what we're going to see is that the pheomelanin, that red yellow pigmentation, is not going to reflect as much UV radiation. And so while we have a very large amount of vitamin D synthesis that is possible, we are also exposing the body to UV damage or breakdown of that vitamin B9. So for somebody who is in a equatorial tropical region, we would really encourage them to make sure that they are taking excess amounts of folate. So that way they are replenishing that possible material that is being degraded by their excessive UV exposure. Now, if we were to flip that scenario and we go up into the upper region, so let's change pen colors here. So let's say up in this region right here, so northern, we are looking at an area that has an angle of insolation that is very spread out. That area, somebody who has high amounts of that pheomelanin, they have less of that natural sunscreen per se, and so they're able to absorb much larger amounts of UV radiation, even though that UV radiation isn't as prevalent as it would be in the tropics. We're going to see that this allows them to do pretty good vitamin D production with very little access to that UV radiation. And we will see that because there's not as much UVA present, that we don't have that severe breakdown of folate that we would in the tropics. Now, if we were to bring somebody in who has very high amounts of eumelanin into this region, we would expect to see that they are going to have a very hard time synthesizing vitamin D because remember, that angle of insolation is causing us not to get higher concentrations of UV radiation, but our pigmentation has been created to where it reflects excess UV radiation. So it's kind of acting like an umbrella, right? That sun's trying to get through that umbrella. And we're going to see that these people have a much harder time synthesizing that vitamin D. We may have early onsets of osteo if they're living in those regions for their entire life and not supplementing. We may also see that their nervous system may degrade or break down more earlier in their lifetime. Now, because they are in a region where there's not lots of UV radiation, we also wouldn't see much breakdown of folate occur here either. So that is just something to keep in mind prior to watching the video. I do think it's a very interesting theory as far as like how those early men and women, where they originated from, how those pigmentations were able to aid them based on the environmental factors that they were surrounded by. Obviously, we're in 2025. We have lots of supplements, all of the things. We can live anywhere and everywhere that we want without having to worry about things such as, are we going to have too much UV exposure and not enough folate in our body? Or are we not going to get enough vitamin D? We have lots of different supplements. You can buy vitamin D at the grocery store. And we also have alternatives. So people who live in places such as Antarctica, for research purposes, or people who live in the Arctic, they actually have synthetic UVB lights that they will lay under for short amount of time to kind of get that synthetic production to begin of vitamin D. All right, so looking at some changes in our pigmentation, the first one is going to be an inherited one. This is albinism. So this is for people who do not have, they have very, very little to no melanin production in their body. So what we're oftentimes going to see is that their skin is essentially, in better lack of terms, transparent. So they are going to have a very red or pink flush to their skin because we do not contain any U or pheomelanin in those keratinocytes of the skin. We will also see that they will not have pigmentation most times in the hair or the eyes either. So the hair tends to be a bright, bright white. We will also see that in the eyes tend to have kind of a gray or violety color to them. Now, due to the lack of pigmentation that is present in the eyes, we do see people with albinism tend to have um, chronic vision issues. So these are going to be things such as maybe severe astigmatism, or it can even be like due to exposure of UV radiation, it can even lead to early onset of cataracts or very just poor visual abilities early on in their life. For the next one, this is our birthmarks and moles. So many of these are going to be present at birth, or they will develop in the very early months or years of somebody's life. Birthmarks and moles are super duper common. It is actually probably more uncommon to find somebody who does not have one. We have tons. There's such a huge variety of different birthmarks and what they're categorized as. For the most part, these are just going to be concentrated portions of pigment in a certain area. Some people they may be larger, some people they may be smaller, and some people they may get lighter or start to disappear as they get older. And for other people, they may get darker or more prominent as they get older. For the most part, birthmarks and moles are not an issue to your health. They have very little to do with the future outcome of your health. Obviously, if you have something like a mole, keep an eye on it. If it is an area that's going to be constantly exposed to significant UV damage, but for the most part, birthmarks, pretty much no worries there. All right, our next one is going to be our age spots and freckles. So these can be either genetic in terms of our freckles, or they can be a response to chronic UV exposure. So certain people are born with freckles already present either on their face or on their body. And we can see that typically if a child has it, one or two of the both the parents may have it, or maybe a grandparent. We see that that tends to be something that usually runs as a physical characteristic with the family line. Age spots, on the other hand, are usually what happens as the skin starts to break down as you get older. And we will see that chronic exposure to UV radiation can cause those age spots to appear when you are much younger or more severely. Typically, age spots are going to occur on places such as the chest and the face because those are constantly being, you're constantly getting exposure even if you don't go outside. UV radiation can come in through the window and even expose your skin there. And we're going to see that due to modern technology, if you have a age spot or a dark portion that is starting and you're not really happy with it, you are able to go to certain clinics or get beauty treatments that are able to use lasers to reduce the appearance of those age spots. All right, our next one is going to be vitiligo. So this is a immune disorder that is going to destroy melanin. So this is actually going to attack those melanocytes and prevent production of pigmentation. So what we will see is that as a person who has vitiligo is aging, they typically will have more and more loss of pigmentation throughout their life. Winnie Harlow is a really great example of somebody who has vitiligo. She uses hers as a wonderful means of expression and advocacy. Typically, with vitiligo, there is not any severe health complications for most people. It is clearly just the loss of the pigmentation. While they may not be happy with the appearance of it, there is no significant correlation with other health issues. If you have ever seen somebody who has vitiligo, they may have certain times where that vitiligo kind of flares up, that autoimmune disorder will flare up, and they will have larger amounts of loss of pigmentation. And then for years after that, they may have no change in the pigmentation of their skin. It's kind of a odd disorder in how it acts. There's nothing that necessarily triggers it or stops it. It just kind of comes and goes as it wants. Our next one is going to be PKU. Please be aware of PKU. You do not need to know how to say or spell the full name, just know it is PKU. So this is a inherited disorder that occurs when we have a person who cannot break down the amino acid phenylalanine. So this is one of the 25 essential amino acids that, when you get to your chemistry and your biochemistry classes in college, you will learn about. So this inability to break down this amino acid is going to cause a buildup of it in the body, and that is going to be toxic to both the brain and the nervous system. While we have the toxicity portion of it possibly impairing neural function or brain function, we also have the unfortunate physical characteristic of it impairing melanin production. So what we may see with people who have PKU is that they may have patches or areas that look very similar to vitiligo.